So here I am in my development environment, my desktop machine. Now you could search through the various folders on your hard drive for the compiler, the C# compiler, but there really is an easier solution. The .NET Framework adds a special command prompt that includes the path to the .NET SDK tools, so you can run the compiler from any folder. In order to find the special command prompt and test out the command line compiler, you just have to do a couple steps. Now, one thing, I'm currently running on Windows 8.1. I know, a little bit old, but it's an operating system I'm familiar with, so I'm running with it. And it's still currently supported. But how you find and load the Visual Studio command prompt may vary a bit based on the version of Windows that you're running. But what I'm doing here should probably pretty much work in at least Windows 7 and later. In earlier versions of Windows, you may need to use the old style button, the old style start button, go to all programs and find the Visual Studio 2015 menu item and then proceed from there. But in this case, I'm going to tap the Windows button. That brings up that screen there. And I'm just going to type in part of the name, VS2015. And there you can see that it finds developer command prompt for VS 2015. And there's another one here that's specialized for building applications. But I want the developer command prompt. So I'll click on that, and that opens up this Windows PowerShell window that has all of the settings set for Visual Studio. Now, this is the first time that I've run this on this particular machine, so it had to do some setup kind of stuff. So it installed the .NET Version Manager, created a destination folder, various things. This is just all to support the use of .NET Framework on this application. Now, I do have ASP.NET 5 installed on this machine, and that accounts for a couple of the things that had to be installed. So if you don't have ASP.NET 5 installed, you may see a little bit different when you first start this command prompt up. But all of that's done automatically for us, and it's a one-time thing, a one-time configuration sort of thing. All right, the name of the compiler, the command line name is CSC for C# compiler. So I can type that in, and then I can do a /?, and that will print out all of the different commands that I can use, all of the different command line arguments that I can use as part of compiling an application. All right, so as you can see, there's a lot of different options. Basically, the things that I'm going to be using are the /out because I need to define where or what file is going to be created. And then as part of that, I also need to specify the input files. But then there's various other things that I can include. A lot of these you generally won't use, but they are available, and you can define additional resources, define how code generation is performed, what optimizations are done, how errors and warnings are configured, and so forth. Now, as a practical matter, if you are going to use the command line tools often, you're probably not going to type in the complete command every time. You'll probably have a batch file or execute this as part of a build file from within Visual Studio. So with real applications, the commands that you need in order to compile code are probably going to be fairly extensive, or the arguments that you need to provide to the compiler. We're going to be looking at a fairly simple example, and so our command line is going to be relatively simple. But just keep in mind, as your applications get more complex, you'll need to take advantage of more and more of these different commands. Okay, so for the time being, I'm going to close that window there. And now I'm going to show you a demonstration of creating a .NET program from scratch, not using Visual Studio, but we're going to go take kind of a lower level view of things and write the code using Notepad and then compile it using the command line tools. And then we can execute it and explore the application. All right, so to do this, I need to start up Notepad. I'll go ahead and maximize that. And then I'm going to type in the code for my application. So for this, I need to define a class, and I'm going to call it the classic Hello World. Okay, so that's the class that is going to contain all of my code. That defines a code block, which is delimited by curly brackets. So I'm going to include the open and closing curly brackets. Now, point of technique, generally, anytime I need to use pairs of characters, open and closing of anything, open and closing quotes, open and closing brackets of various kinds and so forth, I generally go ahead and type in both of them at once. Because in a complex set of code, I might have a lot of lines of code down here, and I may not notice that I haven't done this. I may forget a nested curly bracket. It's just too easy to forget that kind of stuff. So it's a stylistic sort of thing. Now, within this class, I need to define a main method. It's going to be public because it's going to be available outside of this class. It's going to be a static. I'll talk more about that later in the course. It's not going to return anything, so another way of saying that is I'm going to return a void, which means it doesn't return any meaningful value. And I'm going to give it the standard name main. Okay, now within that method, I am going to have code and a code block, so I have to have the open and closing brackets again. And then I can define the code for my method. So I'm first going to include a comment. One style of comment within C# is 2 forward slashes like that. And I'm going to make a note that the following code is going to display text in the console window. Okay, so this is a demonstration of a comment. It's not exactly the most useful comment because the code, as you'll see as in a moment, is pretty obvious. But I just want to show you how to use comments within the code. All right, and then what I'm going to do is I'm going to use the system namespace, and I'm going to use the console class within that namespace and call its writeLine method. And what I'm going to write out is hello world. And then all statements within C# have to terminate in a semicolon. I'll talk about that more later too as well. And there's our complete application. It's pretty much the absolute simplest application that you can write within .NET. So I'm going to save this. I'll do a Control Save. And I'm going to put this in my C drive under Learn Now and Samples. And I'm going to call this test.cs. And I'll change that. Sometimes Notepad insists on adding a .txt if I don't do that. And there we have test.cs. And CS is the standard file extension for C# code files. Okay, so there's my code. I'm going to minimize that for the time being. And now I'll reopen my command line. And so the next thing we need to do is compile the code. So I'm going to use the C# compiler. And then my output for the compilation is going to go to, I'm going to put it in a specific location. I'm going to put it in Learn Now Samples /test.exe. So the name of the executable file is going to be test.exe, and it's going to be in my Learn Now Samples folder. All right, and the input to this is going to be C Learn Now Samples test.cs. Okay, so if I did everything right, I can hit Enter, and the compiler will fire up and compile the application. So the weird thing here is that if the code compiles correctly, you don't see any errors or warning messages. And I don't see any error or warnings messages. All I get is a couple of copyright and notification things there, no messages. So that indicates that the code should have executed correctly or compiled correctly. All right, so I can test my application by typing in C /learn now. I'm hitting the tab key to complete the names of the files. Not test, hit it tab again, test.exe. And I'll hit Enter, and there's hello world. So our code compiled successfully, and I was able to test the application. Okay, so once again, that's just about the simplest possible C# application that you can write. All right, so once again, that's just about the simplest possible C# application that you can write. But in order to understand the sample, you have to understand a few basic concepts about the .NET environment. First, every .NET application has to contain a procedure named main. Now, that's not really an absolute. Particularly web applications sort of don't have a main, at least not one that you explicitly code like this. They're actually called different things, but that's a weirdness for web applications. But most Windows applications that you write need to have that procedure called main, because the .NET runtime is going to look for that method name as the starting point of the application. So it has to have some point where it starts the application. You can have a whole bunch of different code files. So you have to have this public static void main, and that's how the common language runtime knows where to start execution. Okay, and that procedure has to be contained within a class. So you can think of a class as a blueprint for an object. It's the definition of the behavior of the object, and you can create multiple instances of the class in memory based on that same blueprint. In this case, the sample defined the class containing the main procedure using this class hello world. And in this particular case, the class name doesn't matter, because what ultimately matters is that the compiler and actually the runtime is going to find this main procedure, and it just happens to be in this class called hello world. Okay, and as I mentioned, the braces delimit the beginning and ending of the class definition. So everything within this open and closed brackets is the definition of the hello world class. Now, normally, before you can call the code contained within a class, you have to create an instance of the class in memory. So the way to think of it is although a blueprint defines the behavior and the structure of a house, you can't live in a blueprint, rolled up set of drawings that your architect prepared for you. You have to actually create an instance of the blueprint by building a house that uses the blueprint as its plan. So the same thing goes with classes. You can't call the code defined in the blueprint. You have to create an instance of it, an instance of this class, which creates an object in memory. Although the .NET Framework provides a technique for creating an instance of the class in code, which is the new keyword, the .NET runtime must be able to call the main procedure of an application without explicitly creating an instance of the class, creating the main procedure. That's just how the runtime works. So to work around this limitation, in the sample code, I used the static keyword right there. So this is a keyword that describes the behavior of this method. And in this case, the keyword indicates that the .NET Framework should implicitly create a single instance of the Hello World class for you in order to call the class's main procedure. So you don't have to explicitly instantiate Hello World before calling this procedure, because you wouldn't be able to explicitly create an instance of Hello World because this is the first code that's going to execute. Okay, so essentially it's a workaround, but it has a lot of uses in a lot of different ways and in different kinds of applications. Okay, the public keyword here indicates the scope of the procedure. So because I included that keyword here, it indicates that the procedure is available from outside the application, or outside of this class is really more technically correct. Obviously, if the .NET runtime can't see the procedure outside the class, then it can't call it. Okay, and then as I mentioned, the void keyword just indicates that the procedure performs an action but doesn't return any kind of value. Other procedures might return a value, and in fact the main procedure very commonly will return an integer value, which generally indicates success or failure or some sort of error condition that occurred during execution. Okay, but this procedure doesn't return anything. And then also, the main can also take a single parameter, information that's passed in here, which turns out to be an array of strings. And those capture the command line arguments that you might include. So instead of just running test.exe, I might include test.exe space / all caps or some sort of thing that will change the behavior of the application. So I can get access to that by providing a procedure here, or parameters here within the parentheses. Okay, again, this main doesn't use any parameters, so I didn't include them. Okay, then continuing on with the definition of main, code blocks begin and end with curly brackets, so I have a nested code block here. And those encapsulate all of the statements that make up main, what main is going to do. Okay, by the way, C# is a case-sensitive language. So I could not have written the name here using an _m. The runtime would not find that. Okay, so I'll do Control-Z to undo that. It must be an uppercase main. And that also extends to other methods that you define. If you define a method called getData and you capitalize the G and the D of getData, then when you execute the method, when you call it from other places in the code, you have to write it as uppercase G, lowercase et, uppercase D, lowercase ata. Okay, because C# is a case-sensitive language. Okay, then finally I have two lines, one line of code and a comment, that define the body of the main method. All right, so as I mentioned, this is comment. One of the ways of doing comments is with these two forward slashes. I'm not going to get into the details of comments here, but just know that there's a couple different ways of representing comments, but these two forward slashes is definitely the most common way that you'll want to use comments. And what the two slashes say is to the compiler is ignore everything else to the right of these two characters. So it's going to ignore that text right there to the end of the line till it comes across a carriage return line feed. Okay, and then this line of code appears fairly simple, but it does demonstrate a number of different concepts. So the first thing is it uses the system namespace right there. This provides a large number of classes, and in fact it provides the console class that we're using here. There are a lot of other namespaces, they're nested, so I could have a long system.something.something.something.console for another console object that's located within a different namespace within the .NET framework. All right, so the console object provides functionality that lets you interact with the console window. And in fact, what we're going to be doing here is we're going to write a line to that console window. And so I'm going to use the writeLine method and then pass in a string. Strings in C# are delimited with double quotes like that. And it's just going to write out whatever text that I include between those double quotes, passing that as a parameter to the writeLine method. So this is information that I've highlighted here that is passed to that method. The code in that method runs, and it uses that string right there to do something. And in this case, the something is to write it out to the console window. Okay, and then I terminate the statement with this semicolon. Unlike some other languages, C#, most notably Visual Basic, C# doesn't require that lines of code end with a carriage return line feed. It uses a semicolon as a delimiter between lines of code. But what that means is that I can do things like write long lines of code on two different lines. And that is a perfectly valid way of doing this. Because when the C# compiler is parsing the file, it comes to the carriage return line feed, goes to the next line, sees there's no semicolon, and then continues reading the rest of this as a continuation of that single statement. Okay, so that really makes it easy to format your code, particularly for long statements. Format your code so it's more easily read by humans. Okay, now I wrote this code putting the system namespace there at the beginning. But let's say that I had a real application. I have a complex application, I'm doing a lot of different things, I'm dynamically generating strings, I'm reading user input, and so forth. And I'm using this system.console object over and over and over again. Now it's going to get pretty tedious to write system every time. And it particularly gets tedious when I have an object that's contained within a deeply nested namespace within the .NET framework. Again, my example of system.something.something.something.something.console. If every time I wanted to reference the console object, I had to type in system.something.something.something.something ad nauseum, I'm going to get really tired. And that's just more tedious than I want to do. So instead, what I want to be able to do is not have to write the namespace every single time. So I can do that, but in order to avoid typing the system namespace, in this case, or system.something or system.something.something, whatever it might be, I have to then also add one additional statement up here. And it has to be outside my class definition. It's called a using statement because it uses the using keyword. And I can say system right there, and this is a line of code, and so I need to terminate it with a semicolon. Now, anytime the .NET compiler, the C# compiler, comes across an object that's within my code, what it's going to do is it's going to look at the available namespaces that I'm using this shortcut notation with and see if there's a console object that's contained within system. Now, strictly speaking, it's going to check first if there's a console object that's defined within the current code block, but there isn't here. And so failing that, it's going to then look at my using statements to see if it can find a console object that is part of any of these namespaces. Here I have just one using statement. I could have as many as I want. If I'm using a lot of different namespaces, it's very common in my applications, well, I'll have a dozen using statements because I'm using lots of objects from lots of different places. And you can have way more. There's no practical limit to the number of statements. Now, there isn't anything about using the using statement that changes the behavior of the code. All it is when I'm writing the code, it saves me all the keystrokes of typing in system dot every time I use the console or other objects within the system namespace. That's the only thing that it does different. The code that I compile to is going to be precisely the same. No difference whatsoever. Okay, so just be clear on that. It's a convenience. Get in the habit of using using statements. And in fact, all of the project templates within Visual Studio, they generally come predefined. The different kinds of code files come predefined with multiple using statements. And in general, there's too many, but in general, Microsoft has included the using statements that you're likely to need for that particular kind of application.